explaining sensory and motor organization of the nervous system controlling human movements to a friend your age who has no background in motor control. This friend is about college age.
The purpose of the nervous system in the human body is to coordinate all bodily functions. It can be divided into two main categories, the central nervous system and the peripheral nervous system. The central nervous system is composed of the brain and spinal cord and acts as a command station. It takes in surrounding information from the environment and interprets the information that is received. The peripheral nervous system is everything outside of the central nervous system. It is composed of nerves and neurons that transmits impulses to muscles and organs that creates a response. These responses can be either voluntary or involuntary. These systems are constantly communicating with one another to process information and carry out tasks. Sensation and movement are interconnected on a spectrum. This begins with the process of perception, cognition, to action. Among the spectrum are 7 subcategories. Let's start with sensing. There are receptors inside and outside of the body. These are generally your 5 senses, along with pain, and other receptors that tell our bodies how it's positioned in space. Next is perceiving. This is the conscious awareness that stimuli is occurring and the body is trying to make sense of where the stimuli is coming from. Following perceiving is interpreting. This includes high levels of processing and cognition that involves emotional reactions, attention, motivation, and decision making. Now there's conceptualization. This overlaps a little bit with the following step of strategy and planning. This process includes imagining yourself in a situation and how you want to act. Strategy and planning is similar to binary code, the 0 and 1 combinations that computers use to talk to each other. The brain is pre-programming movements like computers do and is already subconsciously preparing itself to move. Strategies and plans are constantly being modified in this stage in order to work towards a common goal. It is able to take the result of an action, of the intended action, and modify it accordingly in order to meet the goal. Then there's activation. It is a movement plan that was created in the conceptualization and strategy phase that is now being sent out. Last but not least, there's execution, where the plan is being executed and produces movement. So what are loop control systems? It's the body's way of receiving and using feedback. There are 2 types of loop control systems. The first one is an open loop control system that is feed-forward, and a closed loop system that uses feedback. Let's explore the differences between these 2 loop control systems. An open loop control system is relatively simple. It is composed of 2 parts, an executive component that acts as a command center and an effector component, something that happens as a result of a command being carried out. Think of this system like a toaster. There are different settings that you can set your toaster for different levels of toastiness that you would want your bread at. Since there are a variety of options and only one option can be selected at a given time, there is only one possible result of a level of toastiness that can occur with a selected number. This system is pre-planned and does not use feedback. A closed-loop control system is slightly different. It is composed of an executive and effector component like an open-loop control system, but also includes an error signal component that helps measure the correctness of an action and is working towards a goal. Closed-loop control systems use feedback and make corrections in order to reach the goal. Think about a heating system in the context of a closed-loop control system. It's wintertime. The thermostat is the executive in this case. The thermostat is set at a certain temperature so that the heater will turn on when the temperature drops too low. Say that the temperature has dropped inside the house. The thermostat detects the change and sends a signal to the furnace to turn on, to do its job, and to warm up the house. The house is finally warm, but the thermostat is set to a temperature so the house doesn't get too warm. The thermostat detects that the house is now warm and should not be continually warmed. Now that the thermostat has received this information, there is a new command. The thermostat is telling the furnace to turn off. The process is a continuous cycle, constantly changing in order to meet a goal. When the goal is met, some actions are halted and only start up again when a goal needs to be reached again. Now let's apply what we learned today in an everyday example. Let's go through the processes of how sensation is transformed into movement and the 7 steps and how this is related to a loop control system. Let's say you're picking up a hot cup of coffee. You're looking at your coffee cup from across the table and that it's steaming hot. This is sensing. You're aware that the cup is across the table from you. You would like a sip of coffee before you're feeling a little sleepy this morning. So you want to pick up the cup of coffee, but there's steam and it's in your favorite mug. You're thinking you might want to pick it up with 2 hands since you don't want to drop your favorite mug. You're leaning forward and reaching your arms across the table to get ready to pick up the hot coffee mug. You grasp the mug lightly at first, but hold it a little tighter before lifting it off the table before taking a sip and putting it back down. Picking up a hot cup of coffee. What kind of loop control system is this? A closed loop control system. You're gripping the cup lightly at first, but you tighten your grasp to ensure that you won't spill the hot coffee on yourself.